I'd like to define relative maximum and relative minimum values by example. In this graph that we have seen here, we have two minimums. As we see right here, they are pointed out right here. Two minimum values. Those are at the bottom of a valley. The bottom of a valley. They're the lowest points in a certain range. Okay, so they're the lowest point in that area. So those are our minimums. Relative maximums are the highest point in its little vicinity, in the set around that. Now, one thing to note here is that we have a relative minimum, a relative maximum at C2 in this example. We have a maximum at C2, that is our x value. But the relative maximum is the height of that, which is f of C2, the output when the input is C2. Similarly, we have relative minimums at the x values, C1 and C3, but the actual minimums themselves are f of C1 and f of C3. The output when the input is each of those values. Now, if we have a function that's graphed, we want to identify the relative maximum minimum and intervals where they're increasing and decreasing, we first want to recognize that we have a maximum right here, and it's a relative because compared to its surroundings, it is the highest point around. So minus 8. Okay, well, we have a relative maximum at minus 8, and the actual maximum is negative 1 because that's the y value for that. So we have a relative maximum at minus 8, that's our x value, and the maximum is negative 1. We have a relative minimum at this point here. It's the lowest point in that region. So we have a minimum, a relative minimum at x equals negative 4, but the minimum itself is minus 9. Now, based off of those two values, we can actually determine where it's increasing and decreasing. The function is increasing up until it gets to its maximum. So from minus infinity up to minus 8, that's increasing. Well, we know that it's decreasing because it's a maximum. It's the highest point. So we've reached the highest point. Now we're going to decrease again. So going from minus 8, or minus infinity, minus 8 to, and it decreases to negative 4, where we have our minimum. And then it will increase from minus 4 to, and this one actually doesn't change direction, so to positive infinity. Let's look at one more example. We want to identify relative maxima or minima and intervals in which it's increasing and decreasing. Well, we appear to have a minimum here, a maximum here, and a minimum here. So the first minimum occurs at minus 3, and our second minimum occurs at positive 3, and our one lone maximum occurs at x equals 0. Remember, those are our x values. Now, the actual maximum, it attains up to a value of 4. So our maximum is 4, and our minimum there is 0. Well, actually, both of those have a minimum value, a lowest value of 0. Now, based off of that, we can determine increasing and decreasing. I'm going to start on this side, and that's decreasing from minus infinity all the way to 3, and then it changes direction. So we'll increase from 3 to 0. It'll change direction again because it's a maximum. So it decreases from 0 to 3. And then it changes direction again because that is a relative minimum, from 3 to infinity.